Hey everyone, and welcome to another tutorial. In this tutorial, we are going to implement this algorithm that I described in detail last video. So if you haven't watched that and you're not sure what's going on, watch the previous video. Otherwise, we are implementing a breadth first search. Okay, so this is going to be a pathfinding algorithm, and pathfinding, going from a start position to an end position, that's something that in any game you're going to need to do. So this is a utility that we should be able to reuse in other games. So let's start thinking that way, and we're going to start creating like packages. So in our source folder, we're going to create another folder and call it utils. And in our include folder, we're going to create a document, call it utils.h. We can open that up. And then I guess here we want our utils. Well, we won't call it utils.c yet. We'll call this pathfinding.c. Great. Okay, so in our C, we'll add some include statements. So pound include rogue.h. That's our main include file that we've included in every other file. And then here we'll include our utils.h. Okay, so our utils.h, it will have a include guard, which is if not defined utils_h, and define it. And again, this just makes sure that this file will only be included once. And if. Okay, so what's this algorithm doing? Well, it's pathfinding. So we'll just create a function and call it pathfind. And it's going to take in two positions. Remember, we have those position structs. We'll call it start and position end pointers. Not quite sure if I even needed this position structure, but well, whatever. Okay, so what else do we have in this algorithm? We have this frontier, which is a 2D array with an index and a 2D array. Yeah, 2D array. So it's going to have, it's just a queue with positions, right? So it's a queue with positions. So we're going to use pointers. So it's going to be double star pointer frontier, and we'll go ahead and malloc it. Malloc, and okay, the maximum number of positions that this could ever hold is the width of our board times the height. So it would be really nice if we had a, say, max underscore height variable times max underscore width. And if these were global variables, we wouldn't need to pass it into here. So let's go ahead and declare these global variables. So we're going to need our include file for that, our main one. And let's add some comments here. So these are our struct definitions here. Let's try and organize our files a bit. And then here are our functions, which we've already commented. So then here we'll just put our global variables. and that was int max underscore height and max, int max underscore width. Cool. And then in our main function, we will define those. Not define, declare. Initialize. Initialize. That's what we'll do. That's the word. Okay, so max underscore height and max underscore width. Now, it's been a while since we worked on this, but if we go to our, I think it was level.c, we can see here we're declaring our height to be 25 and our width to be 100. So go here and say height equals 25, width equals 100. And we'll plug these in to this one. So now, anytime that we want to change the max width or max height, we know we can just change it here, and it will change it in both this function here and in our pathfinding function here. Okay, so now we have a integer array which the max number of positions that this array can hold is max height times max width. Okay, so in this case it would be 4 times 3 would be 12, and you can see there are 12 positions in this game board over here. Okay, cool. Now, might as well just go through and complete initializing this one. So we're going to need some index counters, so ij, and let's go ahead and just do for I equals 0, I is less than max width times max height, and I plus plus. Now we'll do frontier I is equal to malloc. So we're just giving space for each position. These are the positions in the array. So there are 2 integers in a position. So that's going to be size of int times 2. Sorry, this needs to be size of int star times that value. Okay, cool. So now we have our frontier all initialized. Now how about our came from? So this is going to be a triple star pointer. Yay, because basically what you do is you say you access each position in here by an X and a Y. So there's like 2 dimensions there. Then accessing that gives you a position, which is another dimension. Here's maybe where we could use that position struct, but I'm not worrying about it in this tutorial. Okay, so int came from, and that's going to be equal to malloc size of int double star times the max height. So here it's just having height of so we can we'll need a new for loop. So for I, oops, this one up here is I minus 0, I equals 0, and I is less than max height, I plus plus, and that is going to be came from at I is equal to malloc size of int star times max width. Okay, so now for each y position, we have 100 x positions, and then we loop through each of those. Tell there's a lot of loops here. So j equals 0, j is less than max width, j plus plus, and then came from I j is equal to malloc size of int times 2. Okay, so there's our arrays malloced. Now we're also going to want a frontier index, because how the algorithm works is we add something to the frontier, and then we pull out at the index, and then we increase the index. Remember, we had this kind of we had this pointer index counter here. So that's going to be an index, and then we also need to keep track of how many items are in the frontier. So int frontier index equals 0, and int frontier count equals 0. Okay, now we get to start working with the algorithm. So first thing first is, remember we had the start position, and in the came from array, we initialized it to -9, -9. That was just a flag that we decided to use. So say add start to came from, and that's going to be came from. The y position will be start y. Remember, we have this start position up here. Start y, start x as the x position, and then 0 is equal to -9. Okay, then same thing for the y position, which will just, or sorry, this is the x, this is the y. No, y, x is at 1, so there we go. Okay, now we're going to add our start position to the frontier. So in this example, start position was 1, 1. We added it to the frontier position. So, and what I'm going to do is I'm actually going to write a function to do this. So we're going to say add position yx. That'll be the name of the function. We will pass it our frontier, and we will pass it our y position, which is start y, comma, start x. And we need to pass it the index as well. So frontier index. Frontier count, sorry. Okay, so then we'll write this function. So just go up here, and we'll make this one void, so it won't return anything. And what does it take? Well, it takes all these guys. And this is int star star. This is just an integer, integer, and integer. I have the font kind of big, so it goes off screen there, but let's make it a bit small. Okay. Okay, so what are we doing? We're just adding that position to the frontier. So frontier at frontier count, and first add the y position, which is just start y equals start y. This is a very simple function, but I think we might use it a lot, so worth writing it. And this goes up to 1, and that's really all it does. And then frontier count, we've added a position, so frontier count goes up. Okay, so now we've add start position to frontier. Okay, so we've initialized these arrays. Now, first step of the algorithm, add the start position. So now our frontier has one element in it, which is the start position. So then what we want is a while loop, and we're going to say while there is still an element in the frontier. So we're going to say while frontier index is less than frontier count. So remember, every time we take a position out of the frontier, we increment our index. So kind of where we're at now is just this, right? And our index and our count, sorry, our index is pointing at this position here. Yeah. So it's pointing at 0, but our count is at 1. So index 0, count is 1. So we know that there's a position in the frontier to take out. Okay, so we need to basically take that position out. And how we'll do that is just int x comma y and say y equals frontier at frontier index 0. Copy that, and we'll take out the x. Then we increment our index. So if this is all we had, this would just run once, right? This while loop would only run once. There's one position in, we take it out, we increment the index is now larger than the count, we're done. But obviously that's not all we want to do. We now want to add our neighbors, which are these 4 guys here. Okay, so that's going to be another function. We'll just call it add neighbors. And obviously we'll want to pass it the frontier. We'll want to pass it the the came from array. And well, let's start writing it, see what else we'll want. So just up here, we'll say void for now. I think we might change that, but so void add neighbors. And right now we know we need the int star star frontier and the int star star came from. Okay, so we also want to wait. Yeah, we want the frontier. We will want the frontier count because we're going to add to the frontier. So int frontier count. And we will also want our y and x. So comma y comma x. Sorry, those are ints. Okay, so right now yx points to this position, and we want to add these neighbors. So let's just start by adding this guy up here. This is the north position. So north. Now, this position exists because our start position is in the middle, but let's say that our start position was here instead. Then in this case, there is no north position. So we need to check for that. So that's going to be an if statement, and we're going to say if our y value is greater than 0. So if our y value is not greater than 0, then that means that that there is no north position. So okay, so we're going to add this position to the frontier. So remember, we have this function, and it takes frontier count, and our y position, so that's y minus 1, and our x position. Okay, so now this position is getting added to the frontier. Now, how do we handle so that's the one thing we need to do. The other thing we need to do is to keep track of where did this position come from, right? Because how the algorithm works is we add this position, and this position adds this position, and this position adds this position. That creates these kind of arrows that point back to the path. So we can follow that path back, and it gives us our path, right? Okay, so that means we need to add it to our came from. So we're just going to say came from at y minus 1 and x equals okay, so that's referencing where in this kind of 2D array it is, but then we still need to add the values. So 0 is the y value, and then 1 is the x value. Okay, cool. So okay, yeah, so now there's one other case we need to look out for, is what if we've added these 4 positions, right? And then we get to this position and we want to add its neighbors. Well, we know that we're not going to add the north position because we have this check here, right? But when we get to adding this east position, we'll call it, then it's already been added to the frontier by this start position, right? So we don't want to add it in here. So what we're going to do is we're going to do a check. So we're going to initialize this came from array to -1. And then we're going to say and came from at y minus 1 x is equal to -1. So that's just like a flag to say, hey, there's no position here. We haven't already recorded this spot in the array. Hope that makes sense. Okay, if you guys do have any questions about any of this stuff, please do ask, and I'm happy to try and go over it and explain it. But anyways, okay, so this came from needs to get initialized to -1. So we can do that here in this loop where we malloc it. We'll also initialize. So came from ij 0 equals -1, and might as well do both. Okay. And this needs to be 0 there. Okay, so that's just saying, hey, have we already found this position? That's all we're saying. Okay, so that's the north position. And if we do add this position, then that means we need to increment our frontier count. It goes up. Okay, so that's north. Let's do south. So what changes? Well, this needs to be +1, and y, what does y need to be? Well, the max height is 3 in this example, okay? So 0, 1, 2, 3 is the max height. That's that global variable we set earlier. Okay, so let's say if y is equal to 2, then it is less than the max width, but there's still no positions below it, okay? So it needs to be less than max height take away 1, okay? So y is less than max height take away 1. And yeah, the y +1 +1 +1 +1. And I think that's all we need. Okay, then we'll do east and west. So we'll call this east. And now it's x. So x needs to be less than, same idea, less than max width, take away 1. And y now stays constant, and x goes up. And y stays constant, x goes up. Same thing here. Then finally west. So now it's west, so y needs to just be greater than 0. And y goes down, or x goes down. Okay, I'm probably writing some terrible errors into here, but that's okay. So we've added our neighbors. Our frontier count has been incremented. Okay, so now this is a static, this is passing statically. So we're incrementing the value here, but since it's not passing by reference, I think, I don't know, then this is going to be equal to the same value that after this function is called here. Let's say frontier count is 1. Even if we add 4 positions up here, it's still going to be 1 down here. So just an easy fix is now we're going to return frontier count. Okay, so this now changes to int instead of void. Whoops. Okay, so then frontier count is equal to this. And that's just an easy fix. We could have passed this as a pointer, but that was simpler. Okay, now let's see. So we've added the neighbors. The index has gone up. I think that's good. Right, and we're keeping track of, oh, we need to check for our end condition. So what's the end condition? Well, the end condition is that y and x equals the end position. So let's just do a check for that. If that's true, we're done. So we say if y equals end, double equals end y, and x is equal to end x, then we're done. So in this case, we're done, and we just can break. Yay, we found the position. And right now we're assuming that we will always find the position. There may be cases where we don't, but we're not going to handle that right now. Okay, so we've set up this came from array, and if you remember how we trace back to it is we go to our end position, which in this example was here. So 0, 3, we go to 0, 3, and we just follow this. So then we go to 0, 2, which is right here. And we go to 0, 2 here. 0, 2 here is here, so 0, 1. Where's 0, 1? Right here. And then we go to 0, 1, and then that goes to 1, 1, which is here, our start position. And you can see that by these arrows. Okay, cool. So we just need to code that now. So, I guess all we need to do is say here y equals ny. Yeah, let's copy this. Copy this. Copy that. Okay, so we're going to say y equals end y and x equals end x. So that's our reverse starting position. And we're going to say while y is not equal to start y and x is not equal to start x. So while we haven't found our start position, we're going to backtrace. So then we're going to say y equals came from array at y x and 0. Same thing for our x, except that will be 1 and x. Then just to see this visually, we will do a move print w. Just remember that's our ncurses printf function pretty much. And we'll go to y comma x and we'll just print a plus sign. Okay, so I think that's everything. Now, yeah, that's everything, I think. So now we just need to add this function, this file to our make file, because it won't be there. So go to our make file, in Rogue, and we will, here we have our sources. So we just need to add our utils in here. So that's /utils/. Is that right? We don't need that slash. Okay. So that will now include our utils.c. We need to say // you know what? I never know the difference between the two. That looks forward / That just means ignore this new line, basically. So our make file will not error at us. Okay, now let's see what terrible errors we get. Well, that doesn't look too bad. So pathfinding.c4. And here, what are we missing? There could be, well, we don't have anything in here. So that's our first problem. This should also be, for now, we'll call it void. Later, it will return a path, but for now, void. Okay, so copy that, paste it in here, and hopefully that solves that, maybe? Nope. Okay. Oh, it's this. Where's that? Oh yeah, okay, so yeah, sorry, this is just supposed to be y, and that's just supposed to be x. There, okay. Yeah, just because I did that happen because I copy pasted the list of arguments, but they aren't pointers. Okay, let's try that. Whoa, only one error. That's not bad. Okay, so we made it, but we're not actually calling the function, so it won't actually do anything. So now I need to find where in our code. Remember, we had that old function that did path finding, so we have to find that. Was it connect doors? I feel like it was connect doors. So let's comment that out. And oops, comment that one out. We'll just that, and we're just connecting two doors at this point. So let's do it step by step, basically. So we'll just add a get C in there. Is it CH? I think it's get CH. I don't know. Okay, and then make run. Seg fault. Okay, well, then ncurses decided to mess that up. Oh, okay, so this should actually be, well, came from is less than 0, because we were missing the case. Remember, we initialized our start position to be -9, so we wouldn't ever want to add our start position back to our array. Oops. To be honest, I'm not sure. We're not actually using that -9 here, but anyways. Okay, so yeah, we've changed that. Maybe that will make something better. I don't know. So make clean, make. Okay, so it's running now. Let's see if it works. Nope. Does not work. So what the heck? Alright, I seem to have finally found out what was causing that seg fault. Here we have x is less than max height, takeaway 1. This actually needs to be max underscore width. So basically we were excluding a lot of adding positions because obviously max width is 100 and max height is 25. So doing that should solve that seg fault. Also, here we have and, so we're saying while y is not equal to start y and x is not equal to start x, when really we want it to be or, because we want both of them to be equal. So yeah, that should be or. Okay, let's try running it now. So I'll just make clean, make, and make run. And we can see it now. Appears to be, it's trying to connect, I believe, this door here with this door. So it's just going to go there and be done. Show it again. Okay, so right now it is, I mean, obviously it shouldn't be going through walls. And that will be more so. Let's say we wanted to connect this door with this door. Well, we don't want it to go through this wall. We don't want it to go through this room. So that's one thing we'll just have to modify. But now that we have this pretty solid structure for pathfinding, it will be significantly easier to do. So we'll do that in the next tutorial. All right, hope you guys enjoyed this video. Thanks for watching.